What I'm going to show you now is how to use two pieces of precision cut glassware to size cells, bacterial cells and animal cells. This is what's called a stage micrometer. It says slide. I don't know if you can see a little circle in the middle, and it says 1 division equals 0.01 millimeters. There's actually 100 little divisions on there, like ruler marks, inside that circle. And if you just look at the board, there's 100 of those marks going on the slide. We actually use this slide to calibrate this special eyepiece lens called a graticule. Unfortunately, we're not going to see this in action, but you're going to use this to size your cells. So this slide here is actually used to calibrate this, so we know what we're looking at. So let's have a look just briefly at the board. So the stage micrometer, the slide is used to calibrate the eyepiece graticule lens, so we can size cells. And the stage micrometer has 100 divisions on it, and it's labelled as each division is 0.01 micrometers. Now we're interested in sizing cells. Units we use for sizing cells is micrometers. So 0.01 millimeters equals 10 micrometers. Now we're going to look at that slide in a moment. Each one of these small divisions, so that small division is 10 micrometers. And then we're going to use it, then later on in our lesson you will use that to calibrate the eyepiece graticule. I will show you some photographs, and there's a formula to work out the calibration of that. So one eyepiece division, or otherwise known as EPD, equals the number of stage micrometer divisions which match up to the number of eyepiece divisions. I've got a couple of photographs that students took to show you of that when I finish this video, and then the units are in micrometers. So let's go over to the microscope now to see this in action. So I'm going to put the stage micrometer in the microscope, and first thing I need to do once I've clipped it in is to make sure that circle, okay, this circle here is right in the middle, the silver circle. That's where the divisions are. So as you can see on the screen, it's not quite central, so I'm going to center that up. That needs to be right in the middle. Let's just get that focused. So I could use this now to calibrate the graticule, which is here, using the 4x objective, but that's not going to help us size cells. We need to use a higher magnification. So now we're going to go to the 10x objective. And again, I'm going to focus. It's nicely right in the middle of what we're looking at. If it's not, you should move it to the center. Okay. However, I'm not going to calibrate this lens either, because actually that's still not much use to calibrate the size of cells. Now going to the 40x objective. Let's wait for that to come on. Let's just move it slightly. Let's get that in focus. There we go. So you can see each of these divisions is 10 micrometers. So the distance from there to there is actually 100 micrometers. And then what you would then do is put the lens in to calibrate that. We'd use this objective to draw animal cells and size animal cells. But for bacteria and maybe red blood cells, you really want to use because red blood cells are quite small, you really want to use the 100x objective. So again, I move the lenses to one side. I'm not dipping the oil immersion lens in yet. I now put a drop of oil where the light's coming up. And then I move the oil immersion lens into the oil. And then we focus carefully. Oops. Might start again.
Ah, okay.
Oh, you got a lot of it done wrong. What have I done wrong?